Do not follow where the path may lead. Go instead where there is no path and leave a trail. Today, one company has the technology to reduce the size of semiconductor chips by up to 93%. Today, one company has the technology to cut chip packaging costs in half. Today, one company has the technology to develop systems and servers that run on a wide variety of chips. Quietly, without a lot of fanfare and fuss, without the typical hype, one company has developed the technology to help the computer industry make products significantly faster, cheaper, and most importantly, better than ever before. That company is the Panda Project, and this is its story. Recognizing that the packaging of a chip, its housing and connectors, accounts for more than 50% of its costs, Stanford Crane, founder of the Panda Project, set out to tackle the problem.
There are 3 million transistors or so on this silicon, and yet the package itself now is becoming not only the gating factor from the size standpoint, how much room it takes up on the board and the power and so forth, but also then the cost. The cost of the package is becoming more than the cost of the silicon itself.
His breakthrough, a revolutionary semiconductor packaging design, allows processes to be made nearly 70% smaller. What's more, this design can eliminate most of the complex and time-consuming manufacturing steps, potentially reducing chip packaging costs while enhancing yield. The elements of this technical innovation are called Archistrat. Archistrat, architecture orchestrated to make a profound difference in computing power and flexibility.
It is our belief that the Panda Project technology will have a dramatic impact on the computing world.
Archistrat's semiconductor package is a revolutionary new package design that brings together the interconnect density of area arrays and the inspection and manufacturing benefits of peripherally leaded packages. Archistrat's package is named Vespa. Vespa, very small peripheral array. Vespa is designed to provide greater density, higher pin counts, and a simplified manufacturing process. Instead of just one row of connector pins, Archistrat's Vespa arranges 3 rows or more into a smaller space. The net effect is more pins and less space.
If we could take for example, a PowerPC, repackage it to be about 70% smaller than it is now, we could then probably add more pins to it. The pads would actually be farther apart and therefore easier to manufacture than they would be as a quad flat pack.
Archistrat's Vespa eliminates more than half of the most complex and time-consuming manufacturing steps, potentially cutting chip packaging costs in half. The Panda Project is working directly with IBM's Manufacturing Technology Center, not only to develop semiconductor packaging, but also the basic manufacturing technology for Archistrat's chip packaging. This cooperative effort allows the Panda Project to leverage the semiconductor and automation knowledge within IBM MTC.
I think Vespa is an exciting new product technology that is going to offer the kind of low-cost, high-density, high-pin count I/O that the industry is looking for and continue to look for, with a 60% real estate reduction in terms of semiconductor packaging. This offers significant benefits to the whole industry.
The IBM facility also maintains comprehensive testing equipment to ensure that semiconductors housed in the Archistrat package perform more efficiently than their traditionally packaged counterparts.
Basically, what you get is higher performance at a lower cost.
Well, I'm excited about the Vespa technology. I think that there's a real need out in the industry for a high pin count, low cost package for chips that are now increasing in density at a faster rate than the packaging technologies have kept up with them.
Vespa enables designers to use more I/O without space or cost penalties, and allows silicon designers to reduce signal multiplexing. More I/O also benefits the signal-to-ground ratio and makes Vespa an ideal candidate for housing multiple die substrates.
The full potential of the Vespa package will only be realized when semiconductor designers realize that they are no longer I/O limited. In other words, if their design really calls out for 300, 400, up to 600 contacts, they now have the liberty and the ability to offer their designs in a cost-effective package.
A second innovation from Archistrat Technologies is Compass, a three-dimensional new density tool. In place of a single connector pin, Compass places an insulator with one connector on each of the four sides. These clusters are then nested to achieve higher density. The ramifications are enormous. High-density interconnection not only means smaller, faster, potentially cheaper chips, but it also heralds major design improvements for all electronic products. The Compass connectors are currently in use in the Archistrat system, allowing for a high degree of modularity, flexibility, and serviceability. Unlike other interconnect technologies, Compass is designed to be used as a building block for semiconductors and MCMs, as well as printed circuit boards and cables. For these semiconductor applications, Archistrat Technologies has designed Compass PGA. Current chips may have up to 400 connections per square inch. Archistrat's technology enables designers to get up to 1,000 connections per square inch.
Pluggable devices such as the Intel Pentium, using Archistrat scalar technologies, where we've codenamed Compass, can be made the size of a dime. In other words, reduced over 70% in size, and some embodiments up to 90% in size.
The Panda Project has taken the leadership role in developing the fundamental packaging and interconnect technology for the next generation.
Some of the other technologies that we're looking at the Panda Project are free stack, which is a solution that allows very high level of power dissipation with a very small area.
WellTech technology is yet another unique Archistrat design advance. This advance can help increase the connectivity and efficiency of multi-layer printed circuit boards.
The relationship with Panda is a very exciting one for the MTC organization. We view Panda as a virtual company, a company that has some outstanding core technology and core competence.
In order to move ahead, you really have to start abandoning some of the past. But I hope if there's one thing we'll still be doing, it'll be innovating. And we've got a lot of new ideas which we haven't even disclosed yet, which I think will help us stay on that leading edge.
Today, the company that has quietly developed a broad portfolio of patentable technology, the company that has quietly developed products that can help the computer industry leapfrog important technological hurdles, is about to make a lot of noise.